here we have three resistors. As you can see, one of them is marked 5 ohms, another one 10, and another one 15 ohms. What we can do is arrange these in series and in parallel and have a look at what happens to the voltage and the current as the current runs through the circuit. But before we do that, let's measure the resistance first to see if what's written on the outside of the resistor is in fact true. In order to do that, what we'll do is we'll set this up as a device to measure the resistance. So I'll plug this in here first of all, and now second lead into the port for current, and then connect. This one here says 5 ohms, so connecting that up. We can see that's got a measure of 5.2 ohms. Let's check the 10 ohm resistor. Notice that that has a reading of 10.2 ohms. And checking out our resistor C, resistor C, which has a label of 15 ohms, has a reading there of 14.8. So here are our three resistors all connected in series. As you can see, a resistor A, B and C. So the current goes through all the way around there. Here's my multimeter, which I'll connect up as a voltmeter. So first of all, turning this onto the 20, plugging this into this particular port here, and the COM port. And what we'll do first of all is measure the potential difference across the whole circuit, simply by plugging it in to here. As you can see there, I can swap that around and get a positive value. That value is 11.87. So we'll see what the voltage is, the potential difference is across each one of these resistors in series. So the first one here, connect them like this. That might give me a negative value. If it does, not to worry. Okay, so if I swapped it round, that would be positive. That would be positive 1.95 volts. So going to B to B and checking out the potential difference there, and that potential difference is 3.95 volts. Then having a look at the third resistor C, and we find for some reason that is 0. So what's happened? Okay, so I plugged it into the wrong spot there. So that is 5.95 volts. Next thing to do is check out the current. So I'll turn this around and disconnect these, turn this around here to a maximum scale of 20 amps. Plug this in here where it's got A for amps and the COM port here. As an ammeter, this needs to be connected in series. So we'll first of all measure the current across the whole circuit. I'll do this by disconnecting this plugging it in here and getting this second lead into here, and our ammeter there in series, we can see going through the whole circuit at this point at least is a current of 0.39 amps. We'll check out the current going through here, so what I will do is disconnect this and reconnect this to here. Take this and disconnect this, plug that into here and put this into here. So as you can see, this should now be in series, and for some reason there I have plugged it into the wrong hole, so port, I'll plug it into there. I've got a figure of 0.39. So we disconnect this again and plug this into here. So we've got a complete circuit, and put this now across here. Put this in here and put this in here and this one in here, and get a reading there of, it's minus there, but as I said, that's a matter of swapping over the leads, and again it's 3.39. So we'll check out the last one. So I'll disconnect this, connect my ammeter across here, so there again we can see the current is going through the whole circuit, and again we've got a figure there of 0.39. You should now be able to fill out this table and compare the values with what theory predicts. In other words, do the results match with what was expected using the different equations that relate to current electricity? Now, if they don't, then what might be the reason or reasons? Might it be related to unreliable multimeter readings, or might it be related to the fact that you've got a certain amount of resistance with each of those connections between the alligator clips and the resistors? So there are some things to think about.